Today we're going to be looking at hardware multipliers. Now, the easiest way, maybe not the most efficient way, but the easiest way to implement a hardware multiplier is to use the same method that you would do doing long multiplication by hand. So, say you have a 3-digit number times another 3-digit number. You would have 1 times the top number, so 1, 1, 1. 0 times the top number, 0, 0, 0. And then 1 times the top number again. So you would have 1, 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, and there would be your result. So, given this method, it's the shift and add method where you shift for each bit on the second line, you shift the top line over by 1. And you place zeros where on a line that has a 0 in the lower number. So how that works out is your top line here is A2, A1, A0. ANDed with B0. So you would have that would be your top line. Your second line would be your A2 A2 B1, A1 B1, and A0 B0 or B1. So those would be ANDed together as well, because AND is multiplication, 1-bit multiplication. And then your third line would be A2 B2, A1 B2, and A0 B2. And these would be ANDed together. Should have drawn this a little bit smaller so I wouldn't run out of room. But you get the point. Those are your 3 lines. So in this case, B0 is 1. In this case, this is A, and this is B. B0 is 1, ANDed with A0, A1, A2 would give you 1, 1, 1. B1 is 0. ANDed with anything is going to give you zeros. And then B2 ANDed with A1 or A would give you 1, 1, 1. Now it just is a matter of adding them together. This is not added to anything, so this is your dry erase marker running out of ink. And these would be added together in a half adder for your second result bit. And the carry would go to this would be added with this one with a full adder, and the carry from the half adder goes to the full adder. I should have spread this out a little bit more. I apologize. And then the carry from this is added to this with another half adder, and the carry for this is added with this with a full adder, and the carry, and then the result there, and this let's see here. Oh, this is added with this with a half adder, and the carry goes to this full adder. That carry goes there, and then so you're given 6 result bits. I realize my drawing is a little bit screwy at the bottom. Let me see if I could redo this a little bit clearer. Let's see here. I apologize. Wasn't thinking ahead. Okay. So A2, B0, A1, B0, A0, B0. Okay. And then it's A2, B1, A1, B1, A0, B1. And then A2, B2, A2, B, A1, B2, and A0, B2. Okay, and do smaller, and here, this goes down to your result. This is added with A1 B A0 B1, and that's a half adder. And the result goes down to the bit there. Let's see here. Let me. And then A1 B1. That's a full adder. And A0 B2. That's a half adder. And A2 B1 is ended together, and this is the half adder, and that is that's a full adder, and A2 B2. Yeah, that's a little bit more spread out, easier to read. But you multiply the bits and shift, and then add them. So let's go back to this example. 1 1 1 1 0 1 1 1 1 0 0 0 1 1 1. This is A0 or A2, A1, A0, B2, B1, B0. This is A times B. So the first column is just A0 times B0, which is the AND. So that carries straight down. The second number is, this number is B0 times A1 plus B1 times A0. So this is the AND A1 times B0 added with A0 times B1 added together, and that carries down. And it just requires one addition, and the third number, the third digit, is A2 times B0 is here. A1 times B1 is here. And then, so this is, let me see if I can, well, this is A1 or A0, B0, A1, B0, A0, B1, and A2 to B0, A1, B1, A0, B2. That's A2, B1, A1, B2, and this is A2, B2. So it's a sequence of AND gates and adders, some full and some half. I didn't do the carry out of this one, which it goes to here, and this is the carry in, and this would be a full adder. My apologies. Yeah. If you have if you're adding 3 bits together, you use a full adder. If you're only adding 2 bits, like in this situation, you only use a half adder. So you're only adding 2 bits here and here. So you can use and here. So you can use half adders. The rest would be full adders. So, but this is the shift and add method. There are more efficient algorithms out there. But this will do the trick. This is also how you do it in software. Some processors do not have built-in hardware multipliers. They do it by shifting the bits and adding running it, and have an accumulator keep a running total of the shifts and adds, and do it in the microarchitecture, which you'll get into in computer architecture or yeah, computer architecture covers that. The microarchitecture of a processor will do a multiplication in software. The same mechanism in software and a similar mechanism in hardware can be used for division as well. Only you're not adding, you're subtracting. So shift and subtract gives you a quotient and a remainder. So bless you. Bless you. But yeah, it's the basic process, similar to, like I said, the long multiplication method that you learned in elementary school for multiplying multi-digit numbers. It's just easier when you have just lines of ones and zeros, or lines of zeros. If your second number has zeros in it, you'll have lines of zeros in it. So, yeah. But generally speaking, you have, if you're multiplying two n-bit digits, or n-bit numbers, you're going to have a 2n up to a 2n bit result. So two 4-bit numbers, your result is going to be up to 8 bits. Two 3-bit numbers, and you have a 6-bit number result. So any questions on how the multiplier works? Or, I mean, it's fairly straightforward once you once you look back at the elementary school math here and just implement it in the hardware, where ands represent multiplication and adders represent the addition. So yeah.
A1 times BO, 1B0.
A1 times B0 up here. A1 B0 is right here. This bit right here.
Like above it say A1, BO. Oh, BO.
Yeah, it'd be B0 times A1, or A1 times B0 to get this result. Just just like you would do in multiple digit multiplication by hand. They still teach it that way in elementary school, don't they? I don't know how the Common Core does things, and Common Core math doesn't make. I tried with helping my daughter with it one time, and that confused the heck out of me. The shift and add method is the easier method, but I think, just my humble opinion. If there's no other questions, we can call it a day.